This lesson is 8.3. This is on dot products and vector projections. So let's get started. We are given vectors u, which is equal to a1, b1, and v, which is equal to a2, b2. What does this mean? This means from the last lesson we should know that we have a vector u, which is acting a1 in the x direction, or we call I sometimes, and b1 in the y direction, or sometimes what we call j. So we could also write this u as equal to a1 in the I direction plus b1 in the j direction, and vector v is equal to a2 in the I direction plus b2 in the j direction. I, j, k relate to x, y, z. So let's talk about dot product. Dot product, if we were doing dot product with u and v, we would write dot product as u dot v, not surprisingly, and it is equal to a1 vectors plus b1 times b2, so the y's from both of our vectors. The solution to a dot product is therefore a scalar, or just vector. So let's do an example together. Find u dot v. We are given u equals 1, 1, v equals 0, 2. So all we're going to do to find u dot v is equal to 1 times 0 plus 1 times 2. That equals 0 plus 2, which equals 2. Okay, let's do another one. We have u equals 3, 2, and v equals negative 2, 3. So again, u dot v for this example is equal to 3 times negative 2 plus 2 times positive 3. We get negative 6 plus 6, which equals 0. If you get 0 as your answer to a dot product, what that means is that your two vectors are orthogonal. We know this more generically as perpendicular. They are 90 degrees apart from each other. Orthogonal, perpendicular, 90 degrees apart. So let's talk more about this angle between our two vectors that we can have using dot product. That's a helpful thing we can do with dot product, is find the angle between two vectors. So the angle between two vectors can be determined with the following equation. Cosine of theta, or the angle between the two, so cosine of the angle between two vectors, is equal to u dot v over the magnitude of u times the magnitude of v. Magnitude of a vector is found using Pythagorean Theorem, which we should know from last time. So let's start off with this example. We have the same u and the same v for example 1, and the same u and the same v for example 2. So cosine of theta, we're trying to find the angle between cosine of theta, is equal to u dot v. Well, from the first example we found that u dot v was equal to 2, so I'm just going to write 2 over the magnitude of u. The magnitude of u means that we have 1 acting in the x direction and 1 acting in the y direction, and the magnitude is this thing in between. Well, this is just a right triangle, so the way we find the magnitude is by doing Pythagorean Theorem. So we have the square root of 1 squared plus 1 squared, which is the square root of 2. And on vector v, we have the square root of 0 squared, which is 0, plus 2 squared, which is 4. So we have the square root of 4. We could rewrite that as 2. So we get 2 over square root of 2 times 2. The 2's cancel out. We have 1 over square root of 2, or the same as square root of 2 over 2. Hopefully this looks familiar to you. You should know what this angle is. If you don't, you can type in your calculator. We could do, because we are at the point where cosine of theta is equal to rad 2 over 2, you could do cosine inverse of rad 2 over 2. And you're going to get, if you have this in degree mode, 45 degrees. But you guys should know that's 45 degrees, or also equal to pi over 4. Your numbers won't always be nice. Sometimes you'll get, 22.4 degrees. That's something that happens. Sometimes vectors are not 45 degrees away from each other, so be prepared to use cosine inverse. Okay, let's do the next one. So we have u is equal to 3, 2, and v is equal to negative 2, 3. So we had the cosine theta is equal to 0 over, and it totally doesn't matter what anything else is in this one, right? Because we have cosine theta equals 0. The problem is going to be 0. What is our theta? We could do cosine inverse of 0, but you should also know that this happens at pi over 2 or 90 degrees, right? Because they are perpendicular to each other, that's what this means. The last thing we're going to talk about in this lesson is slightly more complicated, but not much. What we're going to talk about is projection. If I want to know how much of a vector u is working in the direction of vector v, we call that projection of u onto v. So the projection of u onto v, or the same as the vector component of u acting in the direction of v, can be evaluated by some of the following equations. We have the projection of u is equal to u dot v over v squared times v. Or sometimes I think it's easier to think about this as the magnitude of u times cosine of the theta in between times the unit vector v, which this is a unit vector v, represented by the vector v divided by the magnitude v. So let's talk about that unit vector v for a second. So let's take this first one from example 1. Our vector v is equal to 0, 2. So we have 0, 2 as our vector v, and our magnitude for v was equal to 2. If we remember, our magnitude was equal to 2. So we have vector v, which is 0, 2, divided by 2, which means all we're going to do, that was supposed to be an arrow, excuse me, all we're going to do is divide each of those things by 2. So 0 divided by 2 is just 0, and 2 divided by 2 is 1. So this gives us the same vector, but on a scale of 1. This means that it is a unit vector happening in that same direction that we had v before. So that's our unit vector. Let's look at the u cosine theta part of this. So let's go back to our unit circle days. If we remember, if we had some angle like this, and let's say that this was 45 degrees or equal to pi over 4, and we were looking at what is the x coordinate of this. What we were saying is, what is the drop down from here? Well, if we were pretending that this was a vector of 1, we were saying 1 times cosine of 45 was equal to the amount in this direction, the amount on my x-axis, which is the projection of that 1 onto my x-axis, which is 1 times cosine of 45. That's the same thing right here we're doing. We're saying whatever vector I have u acting in the direction of v, let's say we had a v vector here, we want to know what the drop down is. So we're going to do the cosine of the theta in between those. But our answer needs to be a vector, so we need to multiply it by whatever unit vector we have. So let's plug all of this information into the number 1 equation. So we have the projection of u onto v, and it's written as projection sub v of u. So we're saying the projection of u onto v. Okay, so we want to take the magnitude of u. We found out before the magnitude of u was square root of 2. And cosine theta was square root of 2 over 2, or if we want to write it in bad math notation, it was 1 over square root of 2. And then we wanted to multiply that by our unit vector v, which was 0, 1. Well, square root of 2 divided by square root of 2 cancels out, so we just have 1 times this unit vector, and that is our answer. That is our projection of u onto v. Let's do the next one. So if we remember, we had a cosine of 90 degrees, which gave us a 0 here. So our projection of u onto v was 0. No projection. 0 things are happening in the same direction. Plug in your battery. That is what you'll get if things are orthogonal, which makes sense. If we have 2 things that are perpendicular, no part of unit v is acting in the direction. No part of vector u is acting in the direction v. So it makes sense that our answer would be 0. So that's it.